Hola, mi clase. All right, Unit 3, here we go. We're doing lessons 1 through 2. I can compare and interpret proportional relationships using multiple representations such as equations, tables, and graphs. Open up that note taker. We have 3 vocab words. They're all technically review from either this year or last year, so I kind of shortened up some of them since we don't need the full definition this time. So proportional relationships, I just said a set of equivalent ratios. So, that's like a half being equal to 2 over 4, which is equal to, like 8 over 16. Those are just what a proportional relationship is just ratios that are equal to each other. So a slope is a number that describes the direction and steepness of a line. We haven't talked much about direction, but we're going to start getting into that. So that's why that change has happened. Slope represents the amount that y changes when x increases by 1. Remember, with our slope triangles, that's our height over our base, right? Y over x. And then we have unit rate. So it's a rate that describes how one quantity changes when the other quantity changes by exactly 1 unit, right? So that's 3 miles per 1, hour. It's really slow, but it's this one. This one has to be 1. Okay, we're going to draw and label line C that has a slope of 5. This was from your homework. I'm going to actually graph 2 of them to show you that you can do a couple of different things. So what most of you did is you started at the origin, which is great, and we can go over. So remember, when slope is a whole number, we put it over 1, so I can go height over base. So I'm going to go 1 for my base, and I'm going to go up to 5 for my height, and that would create that triangle. And then I can do it again, 1 and then 5, and so it would create this line right here. Now you can start these lines wherever you would like, so maybe I start it off to a different point. I'm just going to change my color. So maybe I start it here, but we can still do the same thing. Base of 1 and height of 5, base of 1, height of 5. It did not say you had to make this a proportional relationship. So I just want to give you 2 examples so that you can see that you can do it in multiple places. The most important thing, though, is that our base is 1 and our height is 5. There we go. Sorry, I need to scroll. All right, let's calculate the rate of change. So from last year, rate of change was the same as our unit rate, right? Rate of change can be our unit rate. It can be, oh, that's not what I wanted to do, sorry. Unit rate, which also equals our slope. And then for each, and then determine which one has a lower rate. Lower meaning smaller, the less than, oops, smaller, I can write. All right, so these are 2 different things. We've got Happy Hauling Services, and then we've got Easy Excavation. So these are 2 different companies. We're going to compare them, okay? So one was a graph, one was a table. You saw that in our I Can today, was that we were able to compare them in different representations. But all we're going to do is compare their slopes or their unit rates. So let's go find and create a triangle here. I'm going to use 0, 0 because it's proportional. And then I'm going to draw my triangle to this point right here that works. Be careful, right? This is not going by ones for my y's. So I just need to kind of look like, okay, this is up 50. So I can count that way, or I can count using the bubbles, but I need to count by 10. So 10, 20, 30, 40, 50. And then the nice thing is my base does go by 1. So this is a base of 2. So I'm going to go 50 over 2. I'm going to divide it, either reduce it or divide it. But the nice thing is it comes out as 25. So this is $25 per cubic yard. That's what that stands for. Okay. So now to find it on the other one, okay, the I Can said we were doing proportional relationships. So I can do my ratio of y's over x's. Okay, so I can find these different ones and see if they come out the same. We would actually need to divide, and that's what we practiced a little bit last year. So I would do 196 divided by 8. And for time's sake, and just so that we can get through the whole lesson and not take too much of your time, I'm going to just use a calculator really quick. This comes out as 24 and a half. I'm going to just check the other ones just to make sure it's a proportional relationship. So I'm going to go 490 over 20 as well, just to double check it and make sure that this is coming out as a proportional relationship. Oh, good. That did come out as 24 and a half. And so if I did the last one, right? So this is going to be $24.50 per cubic yard. And now we need to compare them. So 25 is greater than 24.50, right? So we are looking for the smaller one or the less than one. So then it says which one has a lower rate. And so easy evacuation has the lower rate. So we're just comparing their slopes like we did right in our last unit. We actually practiced comparing the slopes as well. The bigger the number, the steeper it is. The smaller the number, the less steep it will be. All right, let's keep moving. It says here for problems 3 through 4, here is a graph, right? Here is our graph. I'll draw an arrow to show you. There's our graph. It's a proportional relationship. They told us that, but also it starts at 0, 0 and is straight. It says write an equation to represent the relationship where X is the number of drinks sold, right? So this is our X. And it says Y is the amount of money collected in dollars. So this is our Y. Okay, so we're going to write an equation. So our equation is going to be Y equals, and we're going to change this. Last year it was KX. Now we're going to say MX. But this still stands for our slope or our unit rate. Okay. M is your slope or your unit rate. So we're just going to go find the slope of this. So I can use 0, 0, and then I can see that there's a point right here at 300 and 200. So I'm going to draw my triangle. The height is 100, 200, 300. And then the base is 50, 100, 150, 200. So I go height over base, and then I'm going to reduce this by 100, and I get 3 over 2. Now we can leave it like that, but if you would like, we can divide it out and get this. So I'm going to write 2 versions. So we can have Y equals 3 over 2x, or Y equals 1.5x. Those are equivalent and equal, okay, because this is our equation that we're using that I wrote over here. Now for number 4, it says use your equation to complete this table. So remember, drinks sold was our X and money was our Y. And so if you feel like you're running out of room at any time, lift your flap up so we can do some work together, and then we'll put our answer back on here. I'm going to do my work off to the side, but if you do not have room to do work, lift that flap up. We should be on the second page anyways, and then we can do our work together. So we're using our equation from up above. I'll use the decimal form just to show you, so because I know we don't like fractions as much. So I'm going to split this. See, I used a different color for you guys. So I'm going to go Y equals 150, but I'm going to times it by 220 because that's what the table says right here. That's that first number I'm using. All right, so we would take 220 and times it by 150, and we get 330. And so that's why the graph doesn't come in handy. Nowhere on there could I have found that. And so that's why the equation is helpful. So we're going to go 330 right there. Now for the next one, it's the y's is what I have. So So you can see y is 1,500. So I'm going to go 1,500 equals 1.5 and then x. Now this is like solving a one-step equation. This is multiplication between 1.5 and x. So inverse is to divide. So I'm going to divide both sides by 1.5. So I'm going to go 1,500 divided by 1.5. And I get 1,000 equals x. And so I put that up here. Again, if you don't have room, you have your flap lifted up, writing all the same work I have. Okay. And then the last one, they gave me x. So I'm going to go y equals 150 times 1, which gets me 150, which makes sense because that was our unit rate or our slope that we got in problem number 3. All right, the table shows a proportional relationship between x and y. What is the constant of proportionality for the relationship between x and y? So this is something I reminded you guys from above, is that when it says it's proportional, we can just take these as ratios. We can actually just use any one we want because it says it's proportional right here. The table shows a proportional relationship. I don't need to check every single one. I can pick whatever one I want. Okay, so I'm going to just do the first one. So 1 and 375 thousandths divided by 25 hundredths. And that's because I'm going to need to move my decimal over twice to divide these. And 25 is quarters. And so I can divide with quarters a little easier. So 25 cents goes into 37 cents once. It's 25. I subtract, bring down my 5, bring up my decimal. How many quarters in $1.25? So $1 is 4, and then 25 cents is 5. And that's why the answer from your homework was $1.50. So if you didn't get this right on your homework, now we know how to do it. We just pick one to divide, and we divide it out to find that constant because it told us it was a proportional relationship. All right, last one says write an equation for the proportional relationship represented in the table. So remember from up above, I told you it was y equals mx. And then this is our slope or our unit rate. And when we say it's proportional, we can do this ratio of y's over x's. So I'm going to just take the first one. I'll do 2,000 over 25, which means I'm going to divide 25 into 2,000. So 25 can't go into 2. 25 can't go into 20. 25 goes into $2. I'm right here. Okay. So there's 4 quarters in $1. So there's 8 quarters in $2. That's 0. Bring down my 0. And then 25 can't go into there. So I would say my slope is 80. And so my equation is y equals 80x. I'm just going to write an m next to that so we understand what we're doing there. Right? This equals our slope. Now, we only can do this ratio situation for proportional relationships. But that's because that's what we're doing, so we can do this. We'll get into non-proportional another time. All right, until next time, adios.